Okay, so the next topic we're going to do is differentiation again. So first part of it, which I don't need to worry too much about, is just looking at what common functions differentiate to. Now you need to know what the results are, so you need to know that sin x differentiates to give you cos x. You don't need to know about this graph. Yes, I've just sketched the graph as best I could to show you that, look here, the gradient is 1, so it's 0, the gradient is 1. At pi over 2, the gradient is 0, so pi over 2, the gradient is 0. And if you keep doing each point, you should get that you can trace out the cos graph. Similarly, with cos differentiates to give minus sine, which I've just realized is upside down. So ignore the black one, and it should be the purple one. It's too early in the morning for me. Tan x differentiates to sec squared x. Now that one's given to you in the formula, so you don't need to memorize that. E to the x differentiates to give e to the x. And ln x differentiates to give 1 over x. So the most important thing is just being able to use those results. So pause it to have a read of this. So it says, find the equations, so there's an S there, of the tangent and normal to the graph of the function f of x is cos x plus ex at the point where x equals 0. And we need to give our answer in the form ax plus by plus c equals 0. Well, first things first, we've got the x, so let's sub it in to get what the y is. So y equals cos 0 plus e to the 0. Well, cos 0 is 1, e to the 0 is 1, so y is 2. So therefore my coordinate is 0, 2. Okay. Then to find the tangent normal, so we need to get the gradient. So to get the gradient, we differentiate. Well, differentiate cos x, that's one of our new ones. Cos x goes to minus sine x. And e to the x differentiates to give e to the x. Since it's a plus in the middle, I can differentiate them separately, just like I could with something like x squared plus 5x. Then to get the gradient, I sub in 0. So when I put 0 in, I get minus sine 0 plus e to 0. Well, sine 0 is 0, e to 0 is 1, so that gives me 1. So for the tangent, we've got that m is 1. So I do y minus y1 is mx minus x1. So y minus 2 equals x. So x minus y plus 2 equals 0. And for the normal, I have to do the negative reciprocal. So minus 1 over 1, so minus 1, that's m. So y minus y1 is m x minus x1. So y minus 2 is minus x. So x plus y minus 2 equals 0. So there's my two equations. Okay, for the next bit, find the coordinates of the stationary point on the curve. So coordinates, stationary point on the curve y equals ln x plus 1 over x squared, and determine its nature. Well, stationary points means the gradient, so dy by dx, is 0. And determine its nature, that means we have to use d2y by dx squared to see if it's concave or convex. So if we differentiate that first of all, so ln x differentiates to give 1 over x. 1 over x squared, I'm going to rewrite that as x to the minus 2. So now I can differentiate that to give me minus 2 x minus 3. Now, if that equals 0, we get 1 over x minus 2x minus 3 equals 0. So I'm going to take that to the side. So 1 over x equals 2x minus 3. I'm going to rewrite what that means. So 1 over x equals 2 over x cubed. I'm going to times both sides by x cubed. So x cubed over x gives me x squared equals 2. So I get that x equals plus or minus root 2. However, if we look back at what y is to sub it in, x has to be positive. I can't put a negative inside the log. So therefore, x is root 2. And if we sub y in, I get ln root 2, so that's ln 2 to the half, plus 1 over root 2 squared. ln 2 to the half just gives me a half ln 2, and 1 over root 2 squared is equal to a half. So my coordinate is root 2, a half ln 2 plus a half. Okay, and to determine its stationary point, we need to differentiate it again. So d2y by dx squared. Well, 1 over x is x to the minus 1. So when I differentiate that, I get minus x to the minus 2. Minus 3 times minus 2 is plus 6. X to the minus 4. And if I sub in x is root 2, I get 2y over dx squared is minus root 2 minus 2 plus 6 root 2 minus 4. Now I'm going to use my calculator because I'm half asleep. So we have root 2, and we'll store that as air. So I have minus power minus 2 plus 6 times power minus 4. So d2y by dx squared is minus 2, which is less than 0. So therefore it is concave. So if it's concave, therefore my point, root 2, a half, ln 2 plus a half is maximum. I'm just going to double check just by typing that into my graph. So it was ln x plus 1 over x squared. Change the window to initial, draw it, and get that it's a minimum. Okay, where have I went wrong? That should be the plus. There we go. So d2y by dx squared is 1, which is bigger than 0. So therefore it's convex. So it looks like that. So it's a minimum. See, it's a good job to always check your graph in your calculator to make sure that your teacher's not lying to you.